Byron, Chen, Quinten, Holley, and Seth, Weston. We're pleased to present our County Road 38 Reconstruction project. So to give you an outline for our presentation today, we're going to go over a project scope so you can become familiar with what all we were tasked with designing in this project. Then we're going to be going into these different individual areas of design, starting with transportation, then going into structural, water resources, and finally environmental. We'll provide you with a current cost estimate for this project, and then we'll discuss some social and economic impacts that this project might have on the Goshen area. So to give you an idea of where this project is located, right now we're located here in Valparaiso, Indiana. Goshen is located there just southeast of South Bend and Elkhart. Zooming in more on Goshen itself, our project is located in the southern portion of the city, near the Goshen Dam Pond located here. And then further zooming in on our project area, you can see the roadway here, which we were tasked with redesigning, including the intersections at State Road 15 and County Road 21 there. So essentially the whole purpose of the project is to increase traffic capacity, safety, pedestrian accessibility for both the intersections at County Road 21 and State Road 15, as well as the corridor in general. We were also tasked with designing a 50,000 square foot visitor center for the city of Goshen to provide an informational space and a little historical museum as well. We're also managing stormwater for the whole entire watershed area, both around the roadway as well as surrounding the roadway. And we're also charged with developing a feasible alternatives for the treatment of 1 million gallons per day of wastewater flow from the visitor center and the subdivisions surrounding the projects. At this point, I would like to invite Byron Chen up to start talking about the transportation aspects of our project.
Thank you, Eric. Okay, my name is Byron Chen, the transportation engineer of the Civil Engineering. First of all, this is the scope of the transportation portion of the project. This project is going to reconstruct the whole corridor between two intersections. The first intersection was the County Road 21 intersection in the west and the State Road 15 intersection in the east. And the west portion of the corridor are classified as the rural part, and the east portion as the urban part. And those are some important design criteria used for the design. All the values we use are took from the AASHTO Green Book, which are shown at top right corner, and also in that design manual. And for both intersections, they are all signalized intersection. And for the design vehicle is WB67, which are typical semi track on the road, and also shown in picture here. And for the west portion, the design speed at 45 miles per hour and 35 miles per hour for east portion. Some people here may know that actually the speed limit is 40 and 30 miles per hour. We are a little over designed for the project. It can ensure the safety. Okay, this is the picture of the County Road 38 and the 21 intersection. Before the project, it was a two-way stop intersection, and it had a lot of traffic here. And for our design, we changed the intersection into a signalized intersection and adding a concrete island for the westbound right turn vehicle. And we didn't change the number of the driving line based on the current condition, but we readjust the length of auxiliary lines based on the traffic volume on different approaches. This picture is a typical cross-section for the corridor. For the pavement part, we decided to use 2-inch HMA surface for and 6-inch for HMA intermediate, 6-inch for HMA base, and also a 12-inch aggregate base under the HMA pavement. In order to saving the cost of the project, we use the different value for the shoulder pavement. Those values are the minimum number two from the design manual. In this picture, we can see there was 3 layers here, and those are the surface, intermediate, and the base layer. Okay, the first cross section was from the corridor from the west intersection to the within center. We have 12 feet wide driving lane, one for each direction, and we can see there we use a different pavement for the shoulder and the driving lane, and also a ditch vegetation on the both sides of the road. It just look like this picture. One lane for each direction, 10 feet pavement shoulder with 1 feet without pavement, and a ditch vegetation on both sides of the road. Next, I'm passing to Alex Baker for more information on transportation project.
Thank you, Byron. As Byron said, my name is Alex Baker. I'm the other transportation engineer for this project, and I focus more on the urban section. Starting off, I'd like to continue off where Byron left off. At this point, this is where the rural section changes into the urban section near the visitor center. Here we have, these are broke. As you can see, we have a median lane, and this median lane is going to be used as a two-way left-hand turn lane. It starts and ends right at the, near the entrance to the visitor center, so vehicles can back up and enter without causing a pause in traffic. As you can see, we have curb and gutter on both sides, and then we also have the ditches on both sides. Continuing on towards the eastern portion, across the bridge, we do not have those ditches anymore, and instead we have concrete storm sewers that Eric will talk about later. But we also have a sidewalk on the northern portion that it's going to be used to take pedestrians from the State Road 15 intersection to the visitor center. And here's just an example of what the road will look like in this more urban section. We have the curb and gutter, and then we have the two travel lanes. We have the two-way left-hand turn lane, and then the sidewalk on the other side of the road. For the State Road 15 intersection, this is the current aerial of what it did look like. And then here is the final design. As you can see, for each approach now, we have 3 lanes. 3 lanes, there'll be 1 left-hand turn, 1 through lane, and 1 right-hand turn lane. On the southern portion of the intersection, we have 2 concrete islands that are going to be used as to safely direct traffic, but also to be used as refuges for pedestrians. And as you can see, the sidewalk continues from the south side and it transfers up to the north side of the intersection, and that sidewalk continues all the way until the visitor center. And then here is the section where the transition between the rural and urban section of road occurs. There's that transition zone, and then the two-way left-hand turn begins. And as you can see right here, because the sidewalk was located on the north side, we wanted to give pedestrians a safe way to get across the road. So we decided to install a hawk beacon, and what that is, here's an example of that. It pretty much acts as a crosswalk at an intersection, but because there's no light there, so pedestrians wouldn't be able to press a button and traffic would stop. This enables that. So pedestrians would be able to walk up, push a button, this light would come on, traffic in both directions would stop, and they'd be able to safely cross the roadway. And then due to the fact that we decided to do a full road closure to through traffic, and the traffic needs to be maintained in the north and south directions on State Road 15 and County Road 21, we developed a detour plan, and this detour plan utilizes County Road 40, and it just brings traffic south and back north to the other side of the project. And this detour creates about a 10 to 15 minute increase in travel time. I'd like to pass it off to Quinten Holley, our structural engineer.
As Eric stated earlier, I'm in charge of the structural portion as well as site development of the visitor center. As Eric stated, I'm in charge of a 2-story, 50,000 square foot visitor center that provides gathering space as well as information for the community as well as visitors coming into it. The gathering space is supposed to be for large-scale events, as well as the information will replace the history museum in downtown Goshen and give visitors information about what's happening currently in the city. Moving along, as Eric pointed out, this is where our site is located. As you can see on the map, the Elkhart River and the Goshen Dam Pond have been an essential part of Goshen since it was platted. So we decided to choose a site that kind of emphasized this feature. So we will be putting our visitor center on the west bank of the Elkhart River. As you can see here, our visitor center is sitting about center in our property, with the river being on the east side. On the southeast side, you can see the detention basin and rain garden that Eric will talk about in his part of the presentation. Up on the northwest corner, you can see an entrance. That is actually Kircher Orchard's current entrance. In agreement with them, we are going to update their parking lot and give them a more modern entrance to their facility in order to use that on our project. The biggest concern about this was actually the floodplain. Goshen has actually seen 2 historic floods in the last year. Last year, we saw closer to a 1,000-year storm, and this year we're seeing close to a 100-year storm. The concern is flooding on that site. However, most of the flooding within Goshen stays to the northern part of Goshen. Even on these historic events, the southern portion is not affected as much, so it's not as big of concern to us. Moving on, we have the beam layout for the site, or for the visitor center. As you can see, we have 3 access points from the first floor up to the second floor for either stair or elevator. It's up to the owner to decide which they would like. And here we have a 3D rendering of what the structure may look like. Obviously, the owner and the architect will choose window placement, door placement, exact materials, and how they want the building to look in the final design. This is just a 3D rendering of what the building will look like. Interior, we have about 50,000 square foot with a 4,500 square foot balcony overlooking the river and the dam pond for visitors to kind of gather and see the environment surrounding the area. Moving ahead with the actual construction schedule. Construction of the visitor center will begin about a year after the construction of the roadway. We want to give plenty of time for the roadway to finish up before we start the construction of the visitor center. The schedule is fairly standard as most steel and concrete constructions are concerned. In total, we're looking about 9 months for this construction. Yeah, at this time, I'd like to welcome Eric up to talk about the water resources.
My whole job in this project was to handle the stormwater, to be able to comply with Elkhart County highway standards and City of Goshen drainage standards as well. The goal is to treat and contain all the stormwater from the roadway and the project watershed. We wanted to infiltrate as much of this water into the ground as possible, and it was a goal by the owner to try and remove 80% of total suspended solids within this stormwater runoff. Examples of that include sand, pieces of roadway, plant material, etc. Just a few term definitions in case some of you aren't familiar. A watershed is basically a region of land that drains to a particular body of water. Runoff is basically the flow of rainwater that doesn't soak into the ground but rather just runs over the ground surface. Detention is the temporary storage of stormwater to reduce flows and help us treat the stormwater through settling. And infiltration is just the process which water filters into the ground through the soil. This is a picture of the contributing watershed for the western portion of our project. You can see here that there is no contributing watershed to the south. That's because the grading on this land here drains towards the south, so we didn't need to worry about this land area. On the eastern portion of the project, it's a very level area, so as far as the roadway on this portion of the project, we didn't have any contributing watershed outside of the right-of-way, but we did have some contributing properties at the intersection. So to give you an idea of where all of these stormwater management structures are located, since it's a very extensive project, I'm going through and telling you where these all are. So starting on the far western portion of the project, we have bioswales, or fancy ditches, essentially, in case you weren't familiar, that aid us in treatment of this stormwater. Located along the roadway, we also have an infiltration basin located at the southeast corner of the County Road 21 intersection, as well as some culverts located beneath the roadway that help transfer water from one side to the other. Continuing eastward, we continue the trend of bioswales, as well as some culverts underneath the roadway that will lead this drainage towards the infiltration basin on our visitor center property, which I'll cover in a little bit. Traveling further eastward, we have a storm sewer system with inlets along the roadway corridor. On the western part of this area, the runoff will be led to an underground storage basin. On the eastern part, the runoff will be led to the infiltration basin located at the southwest corner of the State Road 15 intersection. On the visitor center property, as Quinten covered earlier, we have an infiltration basin as well as a rain garden to treat the stormwater runoff from the visitor center. We also have pervious concrete in our parking spaces for this property, and we're also trying to maintain this tree grove located next to the river as well for ecological benefits. So just explain what the purpose of each one of these structures is. For infiltration basins, it essentially detains our stormwater and reduces runoff rates. It also infiltrates water into the ground. That's the whole purpose. We found that 3 were required for this project just to handle the runoff volumes. Here's a little picture of that in case you wanted to get an idea of what that looks like in real life. So for our bioswales, they're designed to handle runoff flows from the roadway and contributing watershed. The water thriving vegetation within these are necessary for treatment benefits. And as I said, this aids us in treatment and infiltration benefits much more than if you had like a concrete channel or something that you were just throwing this runoff straight towards a infiltration basin. And here's what a picture of that would look like next to a roadway. So for our storm sewers, these are basically designed to handle the runoff from our roadway with those inlets that I was talking about along our roadway. 4 separate sewer sections had to be designed just due to grading constraints on the project. And here's a little, I think most of you know what an inlet looks like, and then that's what it looks like, the storm sewer construction looks like as it's going in. So for our rain garden on our visitor center property, it's designed to treat the stormwater runoff from the visitor center roof and the property. And if it overflows, it's able to overflow into our infiltration basin. And it's designed to resemble and function a terrestrial forest ecosystem. And that's another picture of what this might look like in real practice. So for that underground stormwater storage that I was mentioning, it's just necessary because of our grading elevations within that portion of the project. We couldn't lead all of our stormwater runoff to that infiltration basin at that intersection, so this is necessary. So it will detain and infiltrate the stormwater. You can see the little gap here, that's where the stormwater will be stored within this structure. These are strong enough, designed to be strong enough to be installed underneath parking lots and roadways, so it's applicable in this situation. And then just for our roadway culverts, essentially, like I said, it's just to transfer water from one side of the roadway to the other. You can see, everyone has seen an example of this. And then for our pervious concrete, located within our visitor center parking spaces, it's located in all the parking stalls in both the visitor center location as well as where we're redoing the parking for Kircher's Orchard. And it aids with the infiltration and detention. And how it does that, if you haven't heard of the material before, you can see here that water just passes straight through the material, and it can be used within pathways, parking spots. It's just a little less structurally sound than its non-pervious counterparts, so it can't be used in like driving lanes. At this point, I'd like to hand off the presentation to Seth to talk about our wastewater treatment plant.
Thank you, Eric. So as Eric has stated, I am Seth Weston. I'm the environmental engineer for this County Road 38 Reconstruction project. And just to do a quick recap of the environmental scope, we will be providing wastewater treatment for both the Orchard subdivision and the newly proposed visitor center. So currently in Goshen, they're going under a process of annexing the Orchard subdivision because it's having a lot of septic failures. So the purpose is to provide them, to put them on the sewer line and attach them to this new treatment facility. And then with that, we're having a heavy emphasis on phosphorus removal and denitrification, and this treatment facility will be able to handle a peak flow of about 1 million gallons per day. Just to give you a general idea of the treatment train, I will be walking you through each section of this treatment train as we go along through this presentation and tell you why they're important and what we chose. So to start off with preliminary treatment, the headworks portion of this project includes some bar racks, a partial flume, aerated grit chambers, and equalization basin. So the purpose of the preliminary treatment is to remove unwanted things in your piping system. So now if you get accidentally flush rags down your toilet or any plastics, we don't want that going into the treatment plant and ruining the pumps. And then moving on to the primary treatment or primary sedimentation, we chose to design rectangular sedimentation basins, and the purpose of these is just slow down the velocity of the water as it goes through the treatment facility so it can settle out any heavier organic material that is unwanted in your wastewater. And moving on to the secondary treatment, which is arguably the most important portion of this treatment train. So with emphasis on phosphorus removal and denitrification, a traditional wastewater treatment facility just incorporates an aerobic and a secondary clarifier, but because these don't treat as well for phosphorus and denitrification, we added an anaerobic and anoxic tank. And then that secondary round of clarification is just to settle out any more of that organic material sludge that made it through that first primary sedimentation basin. Moving on to the tertiary treatment, this is where you get that disinfection process. So going along with Goshen's ordinances and practices, we will be chlorinating the wastewater with sodium hypochlorite, and this is to remove any bacteria such as E. coli. And then after it goes through this contact chamber, it will be dechlorinated with sodium bisulfite. And then after our tertiary, we are adding something called post-tertiary aeration, which is incorporated in this cascade aerator. And what you can think of a cascade aerator is just a water fountain. So what that does is add dissolved oxygen into our discharge effluent. And this is important because currently the Goshen Dam Pond and Elkhart River are in a state of impairment. So we added this because dissolved oxygen helps that fish life come back. And then with plans in the future for Goshen to actually dredge the Goshen Dam Pond, hopefully this, the phosphorus removal, denitrification, and that added dissolved oxygen will help bring back the life of that river since it's going to be a staple for our visitor center. And then moving on, so the sludge collected in the primary sedimentation and the secondary clarification is going to go through a process of thickening. So you got to get that compact sludge, and then it's going to go through stabilization and conditioning to remove any toxicity that's in there. And then it'll going through a dewatering process. And this dewatering is important because it's going to reduce the weight and volume of that sludge so that disposal costs aren't as high. And dewatering is going to be done through these sludge drying beds. So just a project cost estimate, we separated them into our different disciplines, and as you can see, the subtotal comes out to just above $47 million. And for our design firm, we charged a 3% fixed rate, and that is from the subtotal, and then as well as a 20% contingency on the project from the subtotal. Our total for the project will come out to just about $58 million. Just to go over some social and economic impacts that are happening during the construction of this and design and construction of this project. Those are those environmental concerns for Elkhart with the Goshen Dam Pond and Elkhart River. And then with the Hawk Beacon, that safer pedestrian accessibility throughout the corridor. During the construction, there will be a lot of air and sound pollution. And then that annexation of the Orchard subdivision is also a key part of the project, assuming that it does get annexed. Some economic impacts. The property values will hopefully increase in the Orchard subdivision as this project comes to a close. And hopefully it'll attract more businesses in that corridor area. A negative impact of this project is definitely during the construction, Kircher's Orchard will not see as much business because the road will be closed down. But hopefully after the opening of the new road, it will see a lot more foot traffic as the visitor center will attract more people to it. So at this time, I'd like to invite my colleagues up to answer any questions you might have. All right, cool. Just want to thank you all for coming again to our presentation of the County Road 38 Reconstruction Project.